Okay. So, so far, I'm assuming that you guys are aware with the basic meaning of sets. What are sets? Okay. So based on that understanding, we will, okay, just a minute. Based on that understanding, we will move towards the Venn diagrams. So in set, we have seen that there is a universal set. Okay, I'm just talking about the terms which we have observed so far. We have observed subset. Then we have seen A union B. We have seen A intersection B. And we have also seen a complement or complement of any set. Okay, so these are the things which we have to visualize in Venn diagram. Now, what is a Venn diagram? So it is a diagrammatic representation of the same set where we usually write the number of elements. Okay, we don't focus more on the elements. We can anyways write the elements also, but we focus more on the number. Like for example, if I say that in set A there are 10 elements, so I'm moreover focused with that number 10. Okay, but still I can write elements also if required. So a Venn diagram starts with a rectangular boundary. This rectangular boundary is called as universal set. Universal set, if you remember, everything whatever we write, every set whatever we get, that should be from the universal set. So universal set is like the main database from where you are retrieving all your required data. Okay. So universal set will comprise will have all other sets whatever is given in the question. So now onwards, if I want to, let's say, make a Venn diagram of set A, I have to first make universal set, and then inside that I will write set A. The sets are represented by circles, while they should be inside. Yes, Aaron, I can understand. We changed the link because simultaneously there are two classes today. Okay. If I want to make Venn diagram for A union B, now try to recall the meaning of A union B. A union B was taking A and B together. Okay, taking A and B together, so there can be multiple possibilities for A union B. Usually we use this. Okay, try to understand this very carefully. In A union B, the first set is A, the other set is B. The common part, which is like an intersection between both the sets, that is called as A intersection B. Okay, and if I want to just get A union B, then it will be all of this. Okay, just look at the green shaded part. So everything of A and B. Now in this everything, you can see that the middle part is taken twice. So from here only the formula of A union B comes into existence. Okay, how we will see. So this green portion represents A union B, everything taken together. Now I'll draw this once again and I'll explain you the formula of A union B. Now these are two sets A and B. Okay, I'm not writing their names because now it is obvious the first one is A, the other one is B. So if I just shade this portion, this is A. If I shade this portion, this is set B. Now in that you will observe that the middle part is actually taken twice. Okay, so how to adjust that mathematically? So let us see. So we have a formula for A union B where we will be mainly talking about number of elements of A union B. As I stated earlier also, that in the formulas we usually write the numbers. So number of elements of A union B will be number of elements of A plus number of elements of B. This is the general thing. Now, since A and B have something in common, which is being taken twice, so I have to remove that middle part one time. Understand this point that we have to take each and every element once. The middle elements were coming twice as per the shaded part above. Okay, we have to take it once. So that is why we have to minus that A intersection B. So this is the formula. Okay, this will be the formula for A union B. Okay. Is there anyone having any doubt in this? Okay, we can move ahead. Now there will be certain different varieties which are usually asked as a question. Okay, so we'll just do them as a concept. So let's say if I want to shade A intersection B. So for A intersection B, hopefully all of you knows it will be the middle part. Okay. At your level, they can ask the question in which you have to shade the required part. Okay. In probability, they will be asked in a different manner, but ultimately you should know what is what. Okay. If I want to find A complement, now for A complement, can anyone tell me that which part should be shaded in this Venn diagram? Ajit,
The middle part.
if you will shade the middle part, then you are saying that we are taking A. Do we need A?
No, what is the question? Can you repeat?
A complement. What will be the shaded portion for A dash? Okay, just for revision, I'll tell you that A dash is not A. Not A means you have to take all the elements which are not in A.
Okay, so the rectangle.
So everything except this circle will be shaded. So if I just draw this circle again, then I have to just shade everything else. This will be the required portion for A dash. Similarly, if I want to find A union B dash, okay, A union B dash means everything except A union B. So in the Venn diagram, A union B, let's say we are drawing like this. Okay, this is the representation of A union B when A and B have something in common. You may also find something like this. A and B are separate. This is also A union B if you shade them. But then A and B have nothing in common. Okay, usually we don't take this, but this is also correct. This is not wrong. Okay, so coming back to A union B complement, which part will be shaded for this? Arnav,
Sir, it would be everything that's like outside of them, outside of the the Venn diagram.
okay. Everything
That would be
outside the Venn
shaded.
diagram or outside these two circles? Because
No,
when
I
you
mean outside the
inside the Venn
circles. No,
diagram
no,
means it will be over here.
no. I mean the
Ah,
circles outside
got
of
it, got
those.
it, got it. So everything except these two circles will be shaded, and that will be the representation of A union B complement. Okay, A union B complement means you need to take everything which is not in A union B. This should be there in your mind whenever you're dealing with such questions. Okay, one more. A intersection B complement. How many of you have mobile? The mobile with which you can access that group. So all your parents' number are there in that group?
Yeah.
Yeah.
Okay, so you have an option. Hopefully you might be having. Okay, please focus in the class. Don't explore the features of Zoom that you can do later. Okay, so just try to do it. Make a rough diagram and then send it either over the Zoom chat, or you can send it on my number also, my WhatsApp number. I'm just writing it down over here. Okay, I want to see within 2 minutes, make it a rough diagram and then shade A intersection B complement.
So my parents are out.
You have phone or not?
No.
Then it's okay. How many of you don't have phone right now? Just raise your hands. Okay, so whoever has, please do the needful and send it ASAP.
Except the middle of the Venn diagram, everything outside the middle of the Venn diagram.
Okay, that's correct. So hopefully everyone agrees with that. So what he said is that except that middle part, everything else will be shaded. So yeah, that is true because A intersection B means the middle part. When we are talking about A intersection B complement, then it will be everything except that middle part. Okay, we will learn few more variations of Venn diagram, assuming your higher grades also. Okay, so I'll make sure that whenever you will do it, whether this year or next year, you will understand these things very well. Next is, let's say if I want to find A minus B. Okay, try to understand this. This A minus B is not a regular something minus something. Because when we say set, so set theory have different operations. We have seen they have union, intersection, complement. They do not have regular plus, minus, multiply, divide. Okay. So when I say A minus B, this is just symbolic. What is the actual meaning of it? A minus B means removing the elements of B from A. It also means removing common elements from A. I'll show you on Venn diagrams, it will make more sense. Okay. Common element means we know that in a Venn diagram we have, whenever we make A and B like this, okay, so the middle part is common. Okay, so when I say A minus B, so in A minus B, just focus on this portion. This is A. Okay, this is A. And from A, you can see that there is one portion of B which is going inside A. Okay, so that part we need to remove. So basically, if I just shade that part, this is the part which will be removed from A. So you will get a crescent type of structure. Okay, let me just shade that. So this crescent type of structure is what we call A minus B. So in the Venn diagram, it looks like this. to make it more clear, you can read the above statements again. And still, if there is any doubt to anyone, you can ask. So if I want to write this mathematically, then I say A minus B is equal to A minus A intersection B. In some books, you will also find it written as number of elements in A minus B is equal to number of elements in A minus number of elements in A intersection B. Now it is obvious that these formulas are applied only on number of elements. So it is like somewhere you will find it written directly and somewhere you will find it written with this. Whichever way you like, you can proceed with that. But yeah, when it is about exams, so please follow what your school is teaching. You should be clear with the meaning. The way what we are using to write is entirely different part. Okay, so A minus B, if I finally shade that part, that will be this. Okay, only this. Similarly, if I want to find B minus A, so now it is quite obvious. It is very easy to understand and replicate the same logic. So when I say B minus A, it means removing elements of A from B. So here it is our Venn diagram. And from the Venn diagram, if I want to do B minus A, then I will just shade the required portion. Okay, this time I'm not doing all the things because it is same. Okay, so this pink portion is representing B minus A, which is mathematically also equal to B minus A intersection B. Now it is very obvious that if you do A intersection B or if you do B intersection A, it is the same thing. Intersection means common elements. So somewhere if you write like this or if you found this, it is not different, it is same. Okay. Now it is time to combine them. If I want to find okay. So for combining, let us verify one statement. A intersection B dash is equal to A dash union B dash. This is a very important law, which is called as De Morgan's law. Okay. The name is not at all important. You just try to understand how they can be proved equal. Okay. So if anyone can explain me that, you can take 1 or 2 minutes to think. And if anyone can explain me that how you're going to do it with the Venn diagram, I would appreciate that. That will be ultimate proof that whatever we have discussed, you have understood. So is there anyone who can explain that how we can prove it? Okay. So it is time to observe. Okay. Be very focused because this is a very important part of Venn diagrams. Okay. This is kind of a final thing, which will be the extremum. It will not go beyond this. So when I say A intersection B dash, so we have seen recently that A intersection B means the middle part. So the complement will be everything except A intersection B. This is quite easy to understand and think. Okay. But talking about the right hand side, what we will do, we will just make different slides. Okay. Like what I'm doing, just observe. I want to put this also. Okay. Now try to observe in the first diagram, I will just shade A dash. In the second diagram, I will just shade B dash. Okay. Then I will try to combine them and I will then check that what is it actually. Okay. So when it is A dash means everything except A. So let me shade it. Okay. Please observe it carefully because this is like a demonstration which I am doing. And this will help you to visualize. I want everyone to finally visualize that how that will be the answer. So this is A dash. Next one is B dash. B dash will be everything except B. Okay. Now once again, I should select them and I can group it. Is it moving together? Yeah, it's moving. Okay, great. Now we can play with these diagrams. Oh, this one is not working. Just a minute. Yeah, now it's working. Okay. So now what I'll be doing, I'll just overlap both of them and then I'll see that which is the part which is not shaded. Okay. Since both of them are of same size, so we may get the result properly. So now here you can see, wow, very good. So here you can see that one was A dash, the other one was B dash. Okay. And we have just overlapped both of them. This is how you have to visualize. Okay. I'll just do that thing again because this is ultimately you should visualize. Okay. Why it is not getting grouped? So you have to just visualize like this, that when you are putting this one slide over the other, then automatically you will get all the shaded part and the unshaded part. Okay. So which is same as what we had drawn earlier in the left hand side. Okay. So this is how we can prove that A intersection B dash is equal to A dash union B dash. Now you might be wondering that how we are going to do that in exam. So in exam, you can also prove it. One method is this Venn diagram. Okay. And the other method is you can take some example. I'll tell you with that also. Okay. What is the meaning of that? So let us say I have a universal set having elements from 1 to 10. Okay. You are free to take any example. A will be 1, 2, 3, 4. B will be 3, 4, 5, 6. Okay. A union B will be 1, 2, 3, 4, 5, 6. Now comes the question part. Okay. So if I want to write A, okay, I need to do A intersection B also. A intersection B will be 3 and 4. Now, if I write A intersection B complement, it means I have to take all the elements except A intersection B from the universal set. So it will be 1, 2, then 5, 6, 7, 8, 9, and 10. This is what we have got in A intersection B. Okay, I'll do the remaining at the top. If I find A dash means everything except A. So that will be 5, 6, 7, 8, 9, 10. If I find B dash will be 1, 2, 7, 8, 9, 10. Okay. And if I take their union, A dash union B dash, so that will be 1, 2, 5, 6, 7, 8, 9, 10. Okay. Try to visualize everything properly. A dash union B dash, as I have taken from above, A dash and B dash is same as A intersection B dash. You can observe that. Okay. So this is like a proof of that law. Okay. We have one more similar type of law for which I will be expecting you guys to give it a try. Before moving on to the second law, I have means if there is anyone having any doubt, any question, you can ask. Is it clear to everyone, whatever we have discussed?
Yes, sir.
Great. Moving on to the next law, that is also De Morgan's law only. Okay, so that is, okay, the last one was A intersection B. So this is A union B. A union B complement is equal to A complement intersection B complement. It is very easy to learn that whatever is the sign over here, okay, this sign will be reversed. So that is how we can learn it. Okay. Both the laws are kind of similar. If you notice this one and this one, they are kind of similar, but the only difference is union and intersection. So for this law, I am expecting you guys to do it. Be quick. A union B dash, we have seen it before also. So I'm expecting that all of you know that which part will be shaded. A union B dash will be everything except A union B. So you have to shade the exterior part of these two circles. This will be A union B dash. Okay. Now the next part is we are going to do the same thing. A dash and B dash. We will shade it over here. So A dash will be everything except A. Whoever can do on their own, you can carry on, and the others who have any confusion, you can see what I am doing. This is A dash and B dash will be everything except B. Now we have to take the commonmost part because this time we have to do the intersection. Okay, so please be clear in the concept that this time we are not taking all of them. We are taking the intersection part. So when I will combine both diagrams, we will just check that which part of the diagram is having two colors, orange and green. We will not consider the part of a diagram which is having only one color. Okay, so I hope that thing is clear to all of you. We are doing intersection, so we will do only that. Okay, so it is time to combine them now. So if I just put it over here, yes, it is clearly visible that only the exterior part is having two colors. If you look at the circles, set A and B, they are shaded with only one color. So they will not be considered over here. Okay. So I hope this thing is clear to all of you. Okay, this can be proved using that example also. If I go to the previous example, what I need A union B complement. A union B complement will be everything except A union B. So A union B is having 1, 2, 3, 4, 5, 6. I'll write the complement directly. So A union B complement will be 7, 8, 9, 10. Okay. Then we have A complement and B complement. We need to find the common part of A complement and B complement. So just have a look at this. The common part of A complement and B complement is 7, 8, 9, 10. That is what we have to take over here. So when I do A dash intersection B dash, it will be 7, 8, 9, 10. I haven't written everything because everything was written for the previous one only. So, but in exam, if it comes, you have to write everything properly. Okay. So both of these, what we have discussed right now, they are called as De Morgan's law. And these are very important from examination point of view. So this completes whatever I wanted to discuss in set theory and Venn diagram. The connection with probability, it was not at all a plan. But if anyone is curious about that, how we have to do it, so I'll just tell you one thing, that probability have a simple formula, favorable outcome over total possible outcome. Okay, so when I say total possible outcome, this is most probably, it will be the universal set, because everything is coming from there only, which we can also call it as a sample space. Okay, so the universal set of this chapter will act as a sample space in probability, and at the top, favorable outcome means anything. If I want to find probability of A union B, let us see with this. So A union B have how many elements? 6 elements. Universal set have how many elements? It has 10 elements. So the probability of A union B will be 6 by 10. I am explaining it in very short, but this is it. If you know all the operations, you can very easily connect them with probability if you have basic knowledge of probability. And rest will be covered when it will actually be there in your syllabus, okay, as per school syllabus. So whatever we have discussed, just make sure you're okay with that, okay? And yeah, it will be fine. You can watch the recording again if there's any doubt in any of the part. And it is all about visualization. That is the main thing. You should be able to visualize. You cannot learn these things. If you'll try to learn, then you may mess up in exam. Okay, guys. So see you on Friday at same time. Link will be same. So please don't get confused. Okay. And yeah, for physics, we'll meet again on Friday. Bye-bye. Take care.
Thank you, sir. Bye.
Okay, bye.
Thank you.